Guys, before starting with the calculation, I would like to tell you that what are the steps follow. So first we need to calculate the maximum current of our particular system. So we'll come to know that what will be the maximum current which will be flowing through our cable. Next is you need to calculate the cable correction factor. What happens, the cable manufacturer mentions the size of the cable as well as the current carrying capacity of the cable at a particular temperature on the cable data sheet. But there are factors which derate or reduce this current carrying capacity of the cable. So that is because of the temperature, or otherwise it is because of the grouping factor. When you lay many cables like beside each other, then it affects the current carrying capacity of the cable. So that is also one factor. Then again, how you lay the cable and where you lay the cable, in air, in ground, or in the duct. Next is we have to calculate the cable voltage drop. Basically after first step and second step, you will choose a conductor or a cable, okay? Then you will calculate the voltage drop for that particular cable, so that you will come to know that it is below the permissible voltage drop, okay, and so that you can finalize the cable for your particular project. So guys, here on your screen you can see the temperature correction factor. So this is basically a chart, okay, which mentions the ambient temperature. These are the like types of cables, okay, which is rated for 60 degree, 75 degree and 90 degree. So we'll consider only this 90 degree, as our solar cables are manufactured to operate unto 120 degrees Celsius, okay. So we'll be considering this particular column for our calculation. So for, as I said earlier, if you see here that the temperature leads to variation in the current carrying capacity of the cable. If the temperature is around 26 to 30 degrees Celsius, you can see that there is no change in the current carrying capacity of the cable. But as you go above 30 degrees Celsius, you can see that the cable current carrying capacity is decreasing, whereas below 25 degrees Celsius it is a bit increasing, okay. And this table tells you about the temperature change when you keep the cable just above the roof. So because what happens, the roof gets heated and that heat is also transferred to the conduit, okay. So the temperature across the cable increases. So depending upon your conduit and roof clearance, this is the temperature which you need to add, okay. So now we'll start with our calculation. So first I am considering the cable calculation for solar panel to inverter application, or you can say from solar panel to combiner box. Basically, as we all know that the modules are connected in series in a particular string. So the current throughout the string will be same. So I have considered the maximum current, that will be the short circuit current of a particular module, but that is given at the rated and standard conditions. So I have considered 1.25 as the over irradiance factor, because the radiance at your site will be more than the standard radiation. So that is why we have considered this factor as 25%. So we get is at 11.36 amps. Then according to NEC, you also need to make sure the cable carries this particular current continuously for long hours. So there is a factor for continuous current. So what you have to do simply, you have to multiply that by 1.25. So you can also skip this step and directly multiply this ISC by 1.5. So this was our first step. Now second, what we need to do, we need to calculate the temperature correction factor. So like I said earlier, first we need to include temperature factor depending upon our atmospheric conditions at the site, okay. So we'll consider for this example that our atmospheric condition is 40 degrees Celsius, okay. So this will be one factor. Then next is, like I said before, that we are considering that the cable will be laid into the conduit, and that conduit will be directly laid on top of the roof. So there will be no clearance between the conduit and the roof. So we'll refer this chart, okay. See, if you see that if you place the conduit directly on top of the roof, then the temperature rise will be 30 degrees Celsius. So simply what you need to do now, you need to add this 30 degrees Celsius to the 40 degrees Celsius of the atmospheric temperature. Then it goes to 73 degrees Celsius. So you can see here that the temperature factor becomes 0.5, okay. One more thing I would like to tell you, that if you want to decrease this temperature, you need to increase the height of the conduit from the roof. So that are the details which are mentioned here. You can refer to this chart, okay. So that was one thing. And the other factor, like I said earlier, it's the grouping factor. So I am assuming that there will be 6 cables in one conduit. So I need to consider for the grouping factor. So you can refer this chart, okay, for your standard calculations. Not more than 40 cables are used or placed in a conduit. So this chart is very much sufficient for you guys. So here, as per our example, I'll consider 0.8. And guys, I would also like to tell you that if you are considering for a ground mounted application and you are laying the conduit like underground, still you have to consider this factor as 0.4, okay. This is one thing. And the other thing, suppose you are laying the conduit below the panel, but as you know, in ground mounted the structure is the structure has height, okay? So there is enough space for air ventilation and cooling, okay? So at that particular point, you do not need to consider this factor at 0.5, 0.4. You can consider it as 0.2. So now what I am doing here, the next step is basically I divide my current by all the factors which I have considered. So first is the temperature factor, and next is the grouping factor. So that gives me a current of 35.5 ampere. So basically what it means that you need to have a cable which at least carries 35.5 ampere. What does that mean? That because of the external factors, the current carrying capacity of that cable will reduce such that it can carry your system current. Okay. So next step is what you need to do. You need to refer to the cable datasheet provided by the manufacturer, and you need to check. See, for an example, I have considered this image. So my current was 35.5 example, okay? So as you can see here, like 3 cables which are more than 35.5 amps. First is 2.5 amps square mm, then 4 square mm, and then 6 square mm. But I'll like to tell you one thing, that you know the standard panels which are of 2 meter by 1 meter, okay, dimension, okay, these panels use a standard cable of 4 square mm, okay, at the output. So and the MC4s are also designed, the connectors are also designed to connect for 4 square mm as well as 6 square mm. So mostly we use 4 square mm for our purpose. But if the voltage drop in 4 square mm is more, then we go for 6 square mm. So that is why first we will consider 4 square mm, okay, because this is what we are going to use at the maximum. As you can see here, the resistance of the cable has been mentioned, but it is at 20 degrees Celsius. But as we discussed that our operating temperature is going around 73 degrees Celsius. So I have calculated here the resistance at 70 degrees Celsius. So I use this value. Actually this resistance mentioned here is in ohm per kilometer. So you need to calculate this value in ohm per meter. So simply divide it by 1000. Okay, so we'll get this value. And then alpha is the coefficient of resistance. So depending upon which copper and which type of copper you are using, as you can see here on the cable datasheet, they have used tinned copper. Okay, so I will use the value or the coefficient of resistance for alpha, that for tinned copper. So I have taken this value. You can find this on the internet. Then I want to calculate the resistance at a temperature 70 degree. Okay, so instead of 73 degree, I have considered here 70. Okay, so you can also consider 73, not a problem. Then I have minus the standard or the reference temperature which is mentioned, that is 20 degrees Celsius. So my resistance at 70 degree will be this. So now what I need to do before confirming the cable for my application, I need to calculate the voltage drop. For every application, okay, there is a permissible limit for voltage drop. In most of the cases for DC, they consider this voltage drop to be less than 2%. So if the voltage drop is going above 2%, you should not use that cable. You should use a bigger cable. So the formula for voltage drop is 2ILR. I stands for the current which is going to flow through the cable, L is the length of the cable, and R is the resistance at that particular.
ये मांग नहीं है दीदी, ये तो सड़क है, वो भी ट्रक को.
So after putting these values, and see, you need to put the value for one way. I mean, see, in DC there are 2 cables, positive and negative. I have already considered here 2. So you do not need to put the length for negative terminal. Only put the length for one cable. So I get the voltage drop at 7.33 volt. The voltage of my string is 798. Okay, so I will calculate the percentage voltage drop. That comes to be 0.918%. So it is well suited for my application. So I will go on with 4 square mm cable. So guys, still I would like to tell you some of the practical tips. Like first thing is that, so whenever the cable distance, okay, goes above 50 or 55 meter, then go for 6 square mm cable. Okay, so until 55 meter you can